Still on integral functions. In this video, we're going to talk about the beta function, all right? The beta function. We've talked about the gamma function in 2 videos already. This is the next part of integral functions, the beta function. All right, let's go. The beta function of m and n is defined as this. The integral from 0 to 1 of x to the power of m minus 1 into 1 minus x to the power of n minus 1. This is convergent, okay? It is convergent for m greater than 0 and n greater than 0. Alright. There is an alternative form of writing the beta function, this time in terms of theta. Watch. If x is equal to sine squared theta, if I differentiate x with respect to theta, dx d theta, what would that give me? I want to show you a shortcut to differentiating this. Simple. The power of sine theta here is 2, so write it down. Then differentiate sine theta, you will get cos theta. Then write sine theta to the power of 2 minus 1. So dx d theta is now 2 cos theta sine theta. So if I make ds the subject of the formula, it will be dx equal to 2 cos theta sine theta d theta. Now, this integral is from x equal to 0 to x equal to 1. So what is the value of theta when x is 0 and when x is 1? Let's go. When x is equal to 0, if I plug in 0 here, 0 is equal to sine squared theta. So if I take the square root of both sides, this implies that 0 is still equal to sine theta. So taking the sine inverse of both sides, okay, the sine inverse of 0 is 0. Yes. So it means that theta is 0 when x is 0. Now, when x is 1, it means that 1 will be equal to sine squared theta. Okay, so if I take the square root of both sides, of course, the square root of 1 is still 1. 1 will be equal to sine theta. So that theta will be equal to the sine inverse of 1. The sine inverse of 1 is 90 degrees. Alright, that is 90 degrees, which is equivalent to pi over 2 in radians. Okay, so this integral is now this. Let's watch. Beta of m and n is now equal to the integral from when x is 0, theta is 0. From 0, when x is 1, theta is pi over 2. Then, what is x? X is sine squared theta. Sine squared theta. Let me write that as sine theta all squared. Right? All squared. Of course, this 2 here is going to multiply m minus 1. Do you agree with me? So if 2 multiplies m minus 1, that will be 2m minus 2. Then I have 1 minus, what is x? X is sine squared theta, all raised to the power of n minus 1. Okay, what is dx? Dx is equivalent to this, that is 2 cos theta sine theta d theta. Yes, let's go ahead. So beta of m and n is the integral from 0 to pi over 2. Okay, this is sine. I'll write this now as, okay, let's leave it like as it is, sine theta to the power of 2m minus 2. Okay, in trigonometry, 1 minus sine squared theta is equal to cos squared theta. It says that cos squared theta plus sine squared theta is equal to 1. So cos squared theta will be equal to 1 minus this. So in this bracket, I'm going to write cos squared theta. Okay, cos squared theta. Now, I can write this as cos theta all squared. So that square is going to multiply this power outside, 2n minus 1, and that will be 2n minus 2. You agree with me? Then these two can come out. We'll be having cos theta, sin theta, d theta. Now see what's going to happen. Let me finish it off here. Beta of m and n is this. The integral from 0 to pi over 2. Okay, let's go. I have sin theta to the power of 2m minus 2, and I have sin theta to the power of 1. So they have the same base. If I add their powers, it will be 2m minus 2 plus 1. And 2m minus 2 plus 1 will give me 2m minus 1. So I'll be writing sin theta to the power of 2m minus 1. The same thing here. Cos theta, the same base. So if I add their powers, it will be 2n minus 1. So I'm writing cos theta to the power of what? 2n minus 1 d theta. So I can write this like this. The integral from 0 to pi over 2 sine 2n minus 1 2n minus 1 theta cos 2n minus 1 theta d theta. So this is another form of the beta function of m and n. Let me rewrite this. Beta of m and n is the integral from 0 to pi over 2. Okay, sine 2n minus 1 theta cos 2n minus 1 theta d theta. There's another formula we should take note of. Okay, beta of m and n is simply m minus 1 factorial times n minus 1 factorial divided by m plus n minus 1 factorial. Sorry. So we should also take note of this. Beta of m and n is m minus 1 factorial times n minus 1 factorial, all divided by m plus n minus 1 factorial. There is a formula that connects the beta function and the gamma function. Yes. Listen. Beta of m and n is simply gamma of m times gamma of n, okay, divided by gamma of m plus n. That is to say that if I'm to evaluate beta of 4, 3, that's beta of 4 and 3, I can use this formula to evaluate it. Okay, it is simply 4 minus 1 factorial times 3 minus 1 factorial divided by 4 plus 3 minus 1 factorial. This is 3 factorial times 2 factorial. 7 minus 1 is 6. That's 6 factorial. 3 factorial is 3 times 2 times 1, which is 6. 2 factorial is 2. And this is 6 times 5 times 4 times 3 times 2 times 1. 6 take away 6. 2 cancel 2. So we have 1 left at the top. 5 times 4 is 20 times 3 is 60. So we have 1 over 60 as beta of 3, as beta of 4 and 3. Okay. Now, what if I want to determine beta of 1 over 2 and 1 over 2? I can easily do this using this relation. Okay. The one that connects the beta function and the gamma function. Yes, the reason is because I know what gamma of 1 over 2 is. It is the square root of pi. So this is simply, using this formula, it will be gamma of 1 over 2 times gamma of 1 over 2. Okay, following this formula, divided by gamma of 1 over 2 plus 1 over 2. That's it. In the video on gamma function part 1, I said that the gamma function of 1 over 2 is the square root of pi. That is it. Gamma of 1 over 2 is the square root of pi. The same thing here, the square root of pi. 1 over 2 plus 1 over 2, which is 1/2 plus 1/2, is 1. And the gamma of 1 is 1. So the square root of pi into the square root of pi is pi itself. So what is beta of 3 over 2, 1 over 2? Yes, we are still going to make use of this. It is simple. Using this, it will be gamma of 3 over 2 times gamma of 1 over 2 divided by gamma of 3 over 2 plus 1 over 2, right? Yes, that's it. So what is gamma of 3 over 2? We know that gamma of 1 over 2 is the square root of pi. Gamma of 3 over 2 is actually root pi over 2. I explained this in the video on gamma function, the first part. So if you have not watched that video, do well to watch so you understand basically what we are doing here. I'm talking about the first video on gamma function. Gamma of 1 over 2 is root pi. 3 over 2 plus 1 over 2, that's 4 over 2, which is equal to 2. So we have gamma of 2. Everything here is gamma of 2. And gamma of 2 actually is 1 factorial, okay, which is 1. Look at it. Gamma of n is n minus 1 factorial. So gamma of 2 is actually 2 minus 1 factorial, which is what? 1 factorial. And that will give me 1. So I'm writing 1 here. So root pi times root pi is pi all over 2. This is beta of 3 over 2 and 1 over 2. Now, we can apply the beta function to evaluate integrals. Using the beta function, integrals like this can be evaluated. In the next video on beta function, we are going to solve problems, okay, on how to evaluate integrals using the beta function. Keep watching, stay tuned, keep following. Subscribe, like, and share this video to your friends and your classmates.